Okay, hi guys. So in this lecture we'll be continuing on seeing more questions on the mixture concepts. Okay, so let's get started. So suppose when we have 2.86 gram of mixture of C4H8 and C4H10. Okay, so this mixture was actually burned in excess oxygen to produce 8.8 gram of carbon dioxide and 4.14 gram of H2O. Okay, so we have to calculate mass percentage of C4H10 in the original mixture. Mass percentage of C4H10 in the original mixture. Okay, so let's get started. So suppose we have x grams of C4H10. Okay, then we would have 2.86 minus x grams of C4H8. Okay, so now when we burn C4H8, we will require oxygen to produce carbon dioxide and water. So let's balance the equation. Balancing would be done by having the coefficients here. Okay, and moles used for this compound would be 2.86 over 36. 36 is the molar mass of C4H8. Okay, and mass produced, or rather moles produced of CO2 would be upon 14. Rather this is 56, not 36. Okay, C4 is 48 and H8 is 8, so 56 is the molar mass of C4H8. Okay, so now we have 56 into 4, which is denominator gets reduced by 14, reduced to 14. Okay, now let's apply the same combustion on C4H10. We'll be getting CO2 plus H2O. Again, let's balance the equation. On balancing, we find that we need that we actually have 4 moles of CO2 again. So moles of C4H8 would be given mass, we assume it to be x upon 58 is the molar mass, and for CO2 we would be doing 2x upon 29, or just 4 times the number of moles of C4H8 would be C4H9 would be produced. Okay, now we have been given that 8.8 grams of CO2 was produced. Okay, so total amount of CO2 produced was 8.8 grams. Okay, so you can divide 8.8 by 14 to get total moles of CO2. Okay, and this would be equal to 2.86 minus x upon 14 plus 2x upon 29. Just simplify this equation and we'll get x equals to 1.7. okay, so percentage of C4H10 in the mixture would be 1.7 over 2.86, which was the overall weight of the compound, into 100, which will give us 60.84%. okay, so now some notes here, that if two reactants react with each other and form more than one product, so how will the reactions look like? Okay, so we have reactants as first carbon and oxygen. Okay, in which C plus O2 forms CO2. So case first would be if we are using 1 mole of each, then after the reaction gets over, 1 mole of CO2 would be produced. Case 2 would be if we used again 1 mole of carbon and 1 mole of 3 mole of oxygen, then after the reaction gets over, it would it would get finished off. 2 moles of oxygen would still remain and 1 mole of CO2 would be formed. Case 3 would be if we react 2 moles of carbon and 1 mole of oxygen, then after the reaction 1 mole of carbon would be remaining and 1 mole of CO2 would be formed. Okay, so now what will happen is this CO2, 1 mole of formed CO2 will again react with 1 mole of remaining carbon atom to form 2 moles of carbon monoxide. So as a result, initially from the previous step or from case 3, we had 1 mole of CO2 formed and 1 mole of CO2 present as a reactant of the previous reaction. What will happen finally is these two would be getting exhausted and 2 moles of carbon monoxide would be produced. Okay, so just remember this reaction. Okay, so excess carbon when reacts with CO2 which is formed, it forms carbon monoxide. Okay, so this was first case in which carbon dioxide reacted with the leftover carbon to produce carbon monoxide. Now let's see this case wherein we have carbon plus half mole of oxygen reacts to form carbon monoxide. So case 1 would be 2 moles of carbon reacts with 1 mole of oxygen to form 2 moles of carbon monoxide, and these two gets consumed completely in the reaction. Case 2 would be 1 mole of carbon and 1 mole of oxygen reacts to form 1 mole of carbon monoxide and 0.5 mole of oxygen would be remaining in the reaction. Case 3 would be if we react 3 mole of carbon and 1 mole of oxygen, we would be having 1 mole of carbon remaining in the reaction. It would be fully consumed and 2 moles of carbon monoxide would be formed. So what will happen in this case is in the previous case, so let's say we had 0.5 mole of half oxygen still remaining and CO was formed. So what will happen after this reaction is that CO, which was 1 mole, will again react with half mole of oxygen to produce CO2. Initially they are 1 mole and 0.5 mole, so after the reaction they would both be exhausted to form 1 mole of carbon dioxide as well. Okay, so this is the final state, so just remember this reaction as well. Okay, so with this we come to an end of this lecture. In the next lecture we will be seeing some more concepts on stoichiometry. Okay.